Okay, here is a classic mixing equation in differential equation, and let me read the question for you guys. So here we have a tank containing 60 gallons of a solution, and we know we have 85% water and 15% of them being alcohol. Now, we have a second solution containing half water and half alcohol. That's being added to the tank. So you can see here's the picture right here, right? And it says that second solution is going into the tank at the rate of 4 gallons per minute. At the same time, this tank is being drained, right? It says right here, it's being drained at the same rate. So you can see from this picture, it's 4 gallons per minute being going out as well. Now, the question is, assuming that the solution is well stirred in the tank, right? We are trying to find out how much alcohol will be in the tank after 10 minutes after this process. So this is actually a really slightly different way to set up the differential equation. And let me give you guys an analogy first, okay? So suppose you have a household like this. And let's talk about money again. So when you have a household, and usually you have to make the money and people will spend the money, right? And usually it's the parents that make the money and then the kids spend the money. Anyway, suppose we have a daily income. Let's say we have a daily income to be $300 per day, right? So that's the amount of money going in. Well, in the meantime, when we also have the expense, let me just do like this. Let's say the daily spend is $100 per day, right? Just keep the number nice and things like that. Okay, now the question is, what's the rate of change of the amount of money that we actually have in the house? As you guys can see, all we have to do is to do $300 minus $100, and you know I can say it's $200 per day, right? So in fact, we are still saving money. That's the idea. In this situation, we are talking about the rate of money going in, and then we have to subtract the rate of money going out, right? In this situation, it's the same thing. Let me write it down here. This is the main idea. So I will put down dA, dt. A stands for the amount of alcohol that we have in the tank. dA dt stands for the rate of change of the amount of alcohol with respect to time. This right here, the idea is the rate of alcohol going in minus the rate of alcohol going out. Keep that in mind. It's just like this idea here. And let me write it down. The rate of, and how do you abbreviate what may be the formula for alcohol? If you don't know, let me tell you. The rate of ALC, this is the abbreviation for alcohol. You can see this on the bottles. Anyway, the rate of alcohol coming in, or let me just say come in. And then we have to subtract the rate of alcohol going out, right? That is the idea. It's just like rate of money in minus the rate of money out. So that's the idea, all right? And now, of course, I have to explain to you guys how we can actually formulate this and that. And that's how we are going to set up. Now, let me just focus on the differential equation part. The dA dt, this is equal to, we have to figure out this first. Well, we should look at this picture here, because this is going to tell me how much alcohol that we have that's actually coming in, right? It said 4 gallons per minute. But right here, it also said half water, half alcohol, right? You do have to pay attention to the concentration of the alcohol for the solution that's coming into the tank. This is just the flow-in rate, right, for the solution altogether. We still have to multiply this, and we have to multiply this by 50%. So in fact, 2 gallons per minute of alcohol that's coming in. But let me write down the computation for you guys. We have to do 4 times half alcohol, which is 50%. So let me write it down like this. All right? And let me do some labeling for you guys for note-taking purpose. This right here, I will just tell you this is the flow in rate. Right? Because we have this much liquid, this much solution that's coming in. But this right here, it's a concentration of the things that we care, which is the alcohol in our case. Right? So be sure you multiply them. This will tell you, and you, of course you know this is 2. This will tell you the rate of alcohol coming in is 2 gallons per minute. Now, we minus the rate of alcohol going out. We still do the same thing. We still have to talk about the flow out rate. The flow out rate is 4 gallons per minute as well. So let's put that down. We will have the 4 right here. Now, here's the harder part. What is the concentration of the alcohol that's going out? Remember, originally it says we have 15% alcohol in the tank. Originally, right? So let me just make a note. Originally, we have 15% alcohol. And for the second solution, this right here that's coming in, it's 50% alcohol. So take a guess what will happen to the percentage of the alcohol in the tank. Is it going to get less or more, or stay the same? The alcohol, it's going to get stronger and stronger in the tank, right? Because right here, this solution contains 50% alcohol. The key is the amount of alcohol in the tank changes. That's why we will have the A, and technically it's A of T. A stands for the amount of alcohol in the tank, and it changes. That's why we have to keep track with a variable, and in fact, that's the function. Now, how can we figure out the concentration though? Because this right here, we have the flow out rate already, but I still have to multiply by the concentration. How can we figure out the concentration? Remember, the concentration, this right here, is equal to the amount of whatever things that you're interested divided by the total volume, right? That's how you calculate concentration of any kind. Amount changes when you have the alcohol that's going out. So we'll label that as A over the volume, which is from the tank. Notice we have 4 gallons per minute coming in. In the meantime, 4 gallons per minute going out. What happens to the volume? Nothing. It stays 60 gallons, right? So we do A divided by 60. And now, this right here, it's a differential equation part. dA dt is equal to 4 times 0.5 minus 4 times A over 60. Okay? So here is the idea. In fact, now I can tell you guys, this is what we know. Okay? And this is the first thing. Do we know the second thing? Do we have any initial condition? We do as well. Because it says initially the tank has 60 gallons and 15% of them is alcohol. So we can say A of 0 meaning initial time. The amount of alcohol initially, because we're talking about amount, be sure you do the total volume times the amount times the concentration of the alcohol. So that's how we can get the amount. We do 60 times 0.15 for the 15% alcohol. This right here gives us 9 gallons, right? This right here gives us 9 gallons. So once again, this is what we know for differential equation, and this is the initial condition. And of course, we also want to know what we want to know, right? At the end, the question is asking how much alcohol will be in the tank after 10 minutes. That means I have to figure out A of 10, isn't it? That's what we want to know. Now, let's take a look on how we can actually solve this right here. But the most important part is, of course, the setup. So be sure you understand everything, all right? Okay, here is the solving part. Here we have this differential equation. Of course, let's multiply this and that, right? So we are talking about dA dt equal to this times that. It's of course 2. And then minus, and you reduce the fraction, we get A over 15, right? And now a few things that you can do. if you don't like to work with fractions, we can multiply everything by 15 first. And I will recommend you guys to do that. So let's do that, of course. Multiply everything by 15, okay? So we are saying we have 15 dA dt equal 15 times this is 30, and then minus a over 15 times that, which is of course just a. Much prettier. Next, we will just multiply dt on both sides because this is still separable. You see, this and that will be cancelled. And when I multiply dt on the right hand side, be sure you put a parenthesis first and then the dt right here. Now, on the left hand side, we have 15 dA, but on the right hand side, we have 30 minus a dt. We have to bring this to the left hand side. Put all the a and dA together, right? So, you know this is going to be in the denominator. We have the 15 on the top. Let's just write it down first. Over, here we have the 30 minus a, and you see this is in the denominator, and then we have the dA right here. And then this is equal to dt. Aha, we can integrate, isn't it? Now, let's do it. Here, this is still good, because on the top, it's just a constant multiple 15, right? On the bottom, this is a linear function, right? It's just 30 minus a. So, what we have is, let's first put down the constant multiple, which is the 15. And then you know this is going to give us natural log, absolute value. Here we have 30 minus a. And now here comes to a really common mistake. Remember, look at the derivative of this. The derivative of 30 minus a is negative 1. Be sure you divide it by negative 1. So I will put this down as 1 over negative 1. Alright? So be sure this is actually negative 15 times the ln absolute value 30 minus a. And we can just make this equal, and we'll put a constant on the right hand side. Integral of 1 in the t world is t, and then here we have it, the c1. Aha! Now, as you can see, this is pretty much negative 15 times ln of this, and this is equal to that, right? So, of course, we'll have to get rid of the negative 15. To do that, of course, let's use the blue pen. Let's multiply everything by negative 1 over 15, okay? This and that will cancel, and we will just have ln, absolute value, 30 minus a, and this is equal to this times that, which is negative 1 over 15 times t. And here is the best part. When we do negative 1 over 15, which is a constant, times another constant, it is still a constant. Let's write this down as plus c2, okay? Next, e to the power, e to the power, so this and that will be cancelled. Now, this is still technically absolute value, and then we have the 30 minus a inside like this. And this is equal to, you know, e to, this is the power. And when we're adding powers, you can break them apart. E to this power times e to that power. E is a constant. C2 is a constant. E to the C2 is still a constant. Let's write that down as C3, and let's put that down first. And then we have this part, e to the negative 1 over 15t. Next, we get rid of the absolute value. Get rid of it, plus minus on the right hand side. And then we see this is 30 minus a equal to plus minus c3 is just c4, all right? And then we have e to the negative 1 over 15t. Next, let's bring the 30 to the other side. So we are talking about negative a equal to negative 30 plus c4 e to the negative 1 over 15t, like this. At the end, we have to divide everything by negative 1. So that they cancel, I get the a by itself, finally, right? And this is, of course, positive 30 now. C4, it's a constant. C4 divided by negative 1. You can say that's negative C4. But let me write this down as plus C5. Get used to this. Constants are a lot of fun. And maybe next time, if you're helping your little brother or your little sister, or maybe your kids or whatsoever, if they're asking you, what's 5 plus 8? real. You can just tell that it's a constant. That's it. Anyway, this right here is what we have. And then e to the negative 1 over 15t. Okay? Now, this right here, it's pretty much my amount equation. I'm done. Let me just write it down as a of t, which is equal to this. With this initial condition, let me write it down. A of 0, which is equal to 9. This is telling me that I have to plug in 0 into t. Then you see we have 30 plus c5 e to the negative 1 over 15 times 0. You know, this is pretty much e to the 0th power, which is just 1. This is just c5, right? 9 is equal to 30 plus c5. In other words, c5 is equal to 9 minus 30, which is negative 21. And finally, we have our equation. A of t is equal to 30 is still 30, but the c5 is negative 21, so we'll write it down as minus 21. And then e to the negative 15t like this, okay? At the end, what do we do? Plug in 10. That's it. So at the end, we do a of 10. And this is 30 minus 21 e to the negative 1 over 15 times 10, like that. And use your calculator or whatsoever. I will use a calculator right here for you guys. Right. And the answer that we have is 19.218, and then you have the rest, of course. And suppose we're just going to round it to the nearest hundredths place. So I can tell you this is approximately 19.22, all right? 19.22. And remember, the amount is in terms of gallons. So after 10 minutes, the amount of alcohol that we have in the tank is approximately 19.22 gallons. And here we are done like this. That's it.
So good.